Welcome to the future of agriculture. This is ICICLE's AI cyber infrastructure for end-to-end processing of digital agriculture use cases. As a user of this framework, you can easily compose and manage your jobs all from one convenient and user-friendly interface, which is connected to an HPC backend where your jobs will be accelerated on modern GPUs and CPUs in a distributed fashion. Let's get started. The dashboard is your control center. Here you can select from many modules to compose your new jobs. Depending on the nature of your job, you can take advantage of one or a combination of modules, including data collection and preprocessing, image labeling and high-performance model training, model inference, and visualization of results. The dashboard provides a comprehensive overview of your resource usage, data storage, and processing times, helping you optimize your operations and manage your resources efficiently. Let's walk through an example of creating a job which uses all of these different modules. The use case here is classification of growth stages in a cornfield, where the goal is to train and use a deep learning model to analyze phenotypic data and provide detailed insights on the growth stage. Let's create the new job. The first stage is data collection and preprocessing, where you can import your data from Model Commons or upload it from your edge device directly. Once the preprocessing is done, we will have access to download and examine the preprocessed dataset. For now, let's move on to the next step, which is the model training. This page shows a list of model training options. The values will be populated by default for beginner users. At the same time, advanced users can adjust the training hyperparameters. The domain expert will then provide a number of labeled images for each class. This current page shows the first growth stage class, as shown in the very top. We can navigate through the samples and select representative images. Then we'll click Submit to move on to the next class to be labeled. Once the images are labeled for all the classes, distributed DNN training will be submitted automatically on behalf of the user. In the job overview, the progress of the model training is displayed, showing the current epoch, the overall progress, and the expected time left for completion. For inference, the user can select the inference task they wish to perform. In here, our task, again, is growth stage classification. Then we can select the model to use for inference. We can hit Submit, and that will take us back to the job overview page. Now, let's go to the final stage, which is visualization. The heat map is a view of the entire field. There are several blocks, each one of them is color-coded based on its predicted growth stage. The user can click on individual blocks, review the zoomed-in images, and provide feedback to the system if they think the classification is incorrect. Finally, let's look at the results gallery. Here, the user can examine individual images, their predictions, and the confidence score provided by the deep learning model for that specific prediction. This job is now considered complete, so let's quickly go back to the dashboard. We can see the updated account statistics with the remaining SUs and storage. The new job list now shows the job that was just completed, and the user always has the option to go back and visit completed jobs. This concludes our overview of the framework, so thank you very much for listening.